Columbia, give me 5. Nice. Hands down. Let's do parts D, E, and F together. So if this company that makes all this peanut butter is going to make 2,000 containers total. Oh, did I? Let me find it. There we go. If the company decides to produce a total of 2,000 containers of regular, how many containers of new would it produce? Now, let me pause because I told some of you incorrectly, and that is on me. Okay? If I would have read the question carefully, I would have understood that it's asking to compare regular to new. Okay, we don't know how many new yet, so I'm going to leave our tape diagram not shorter or longer. Let's do this one together. Okay, how many containers of regular are they going to produce?
5.
No, how many containers of regular crunchy peanut butter? Read the question. Vivian? 2,000. Right? And we want to know how many new. How many of the containers will they produce that will be new? So, what ratio can we use? Kalia?
4 to 5.
Yes, because we're talking about regular to new. 4 to 5. So how many parts should our regular tape diagram have? 4. And how many parts should our new tape diagram have? Cecile?
5.
5. So it should be longer, right?
Yes.
By 1 more. If we know the value of this tape diagram is 2,000 and that it has 4 equal parts, can we figure out the value of each part?
Yes.
Can we?
Yes.
Can we?
Yes.
How? How, Cecile?
Okay, so what you do is you divide 2,000 by 5.
Just a moment. Waiting on 100% at level 0.
Oh.
Go ahead.
Okay, what you do is you divide 2,000 by 5 because it's the regular.
By 5? How many units do we
four,
have?
sorry.
There we go.
Sorry.
Okay.
And then so it equals 500.
Yes, it does.
So
each
one,
unit is
500.
500 what?
Crunchy peanut butter?
Containers.
Containers.
Right, good. 500.
Excuse me.
Okay. So then how much or how many new containers of new extra crunchy peanut butter did the company make, Leilani?
500.
What?
Wait, no. For the new?
So they made 2,000 total regular. Well, each one of these is worth 500. Marina, help her.
2,500.
How'd you figure that out so fast?
Yeah,
Columbia, give me 5. Hands down. Check your voice level. Marina, how did you figure that out so fast?
When I was looking at the 2 units, I put plus 500 plus 200
2,000?
equals 1,000 for 500. So I plus another 1,000 and then there was 500 left over.
Yeah, so she imagined that we had gone ahead and written 500 in each box. She knows that this is 1,000, this is 2,000 plus 500. It's 2,500 containers. Yes, ma'am.
You can also say that we already know that 4 is 2,000.
Just a moment, Julie. I'm sorry. Your phone should be open to today at the top left corner of your desk. If it's not, do that now. Julie, what were you going to tell us?
You also could know that 2,500 is because you know 4 is 2,000.
Mm-hmm.
And then there's no ratio.
Yeah, we already know up here that 4 units is 2,000. So we just have to add one more. You could do it that way too. Good. Part E. Now the company wants to make 10,000 containers of new crunchy peanut butter. How many regular ones would they make? Should we draw tape diagrams again?
Yes.
Did I trick you by the way I asked that question?
No.
Yes, some people. Okay, so pay attention to what I'm asking you. We should, because we're still comparing new to regular. Okay? How many units should I draw for the new crunchy, extra crunchy peanut butter, Kalia?
4.
4 for the new kind?
No. 5.
5. How many units for the regular crunchy kind, Julia? 4. Now, how many new did the problem say the company wants to make? Michaela? Say it loud. 10,000, yes ma'am. So, can we find out how much each unit is worth, Jeffrey? Yes, how? Yes, and you get what? 2,000. So each unit is worth how much? Say it.
2,000.
Good. 1 unit is 2,000 containers. So, how many containers of regular would the company produce, Devin?
8,000.
8,000. Good. Good job. Okay, last part of this problem. If the company decides to only produce 3,000 containers of new crunchy peanut butter, how many containers of regular crunchy peanut butter would it produce? Should we draw tape diagrams again? Yes. New to regular, 5 to 4, right?
Yes.
Make sure you draw your units the same size because they're equal units. How many new? Say it. Say it.
3,000.
Thank you, Rocco. On it. Now, can I figure out how much each unit is worth?
Yes.
Yes. How do I do that, Judas? Could I take the total and divide by something? What could I divide by? The number of units. How many units are in that tape diagram? 1, 2, 5. What's 30,000 divided by 5, Ricardo?
6.
6? What? 6? That's it?
100? 600?
There we go. No, not 600. Oh, yeah. Sorry. Sorry. So each unit is worth what, Michaela? Huh? I can't hear you all the way over here. The question was, what do I divide 3,000 by to find what each unit is worth? And Judah said the number of units, which is 5. So 3,000 divided by 5 is 600. So each unit is worth 600. Good. So how much regular peanut butter should they produce? How many containers, Julie?
24,000.
24,000? Devin? 2,400. That's okay. That's a big difference though, right? It's a big difference. That would be a lot more than the new one. And more people like the new one. They'd have a lot of regular crunchy peanut butter sitting around. Nobody buying it. 2,400. Okay? Now, turn to page 33. We're moving on to lesson 8. Yes, ma'am? Oh, how did I get 2,400? Good question. Let me find my, here we go. Okay, I got 2,400 because each unit is worth 600 and I have 1, 2, 3, 4 units. 6 times 4 is 24, right? And we bring down our zeros. 2,400. Does that make sense? Awesome. Okay, let's keep moving. Lesson 8. Exercise 1. Okay, so I want you to look at these 4 ratios on page 33 at the top. And raise your hand if you know 2 of them that are equivalent. I'll give you a second to look at them. Find 2 that are equivalent. Which 2 of them could be equivalent, Javier?
1 to 2
And,
and 5 to 2.
yes, 1 to 2 and 5 to 10. Now, how'd you know that?
Because 5 times 2 is 10 and 1 plus 1 is 2.
Well, how are those related? How are the 2 ratios related? Ooh. Can I use one of these guys?
Yes.
Javier? What's my C value? What could I put here? 5. Boys. Stop. Good. Okay. So yes, because I use the same value multiplied by each number in the first ratio to get the second ratio, they are equivalent. Now we have 2 left over. Leilani. They're equivalent, she says. How do you know?
Because 6 times 2 is 12 and 16 times 2 is 32.
Beautiful. So your C value is
2.
2. Nice. Now, we're going to talk more about ratios and fractions in the second part of exercise 1. Because the second part asks, find the value of the following ratios. It's the same ratios as above, right? And leave your answer as a fraction, but rewrite the fraction using the largest possible unit. So, we need to write the ratio 1 to 2 as a fraction. What could I write? What could I write, Tony? Remember this?
Yes. You'll write for the first ratio,
Mhm.
you'll write 1/2.
1/2. What about the second ratio, Itzel? Yes, 5 over 10 or 5/10. Oh, hold on. It says rewrite the fraction using the largest possible unit. So, how can I rewrite that, Isaiah? Five tenths is the same as. No, help him out, Persephone. 1/2. How'd you find that? How'd you find 1/2?
Because if you take half of 5 tenths, you get 1/2.
If I take half of 5/10, I get 1/2? If I take half of 5/10, I get a different fraction. Javier?
Because you have to divide 5 and 10 by 5.
Yes, he divided both the top and the bottom by 5. 5 divided by 5 is 1, and 10 divided by 5 is 2. Good. Now let's talk about the second part. How do I rewrite this ratio as a fraction? Kevin? Yes, 6/16. Can I reduce this fraction, Shay?
Yes.
What can I do to reduce it?
16 divided by 6.
Can I divide 16 by 6 and get a whole number? No. What's the largest number I can divide both of these by and get whole numbers?
6.
Can I divide 16 by 6 and get...
I'm in 10 divided
It's okay.
by 6.
I need to divide 6 by something and 16 by something and get 2 whole numbers. Davian?
By 2.
Divide by 2. And I get what? Jordan, I get what? 6 divided by 2 is?
6 divided by 2 is 3.
And 16 divided by 2 is?
6 divided by 2 would be
8. 3 eighths. Now let's look at 12 to 32. How do I write it as a fraction, Tara? 12 over 32. Can I reduce it? What's the largest number I can divide each part by? 6? No.
8?
No. 4. And I get what, Wesley? What's the fraction I get now? Go, Javier. What's 12 divided by 4? And what's 32 divided by 4? 8. Are these the same? Yes, these two ratios are equivalent. Are these the same? Yes, these two ratios are equivalent. Now, let me pause here. Are these two ratios the same? No. Do they have the same value? Yes. They are different ratios with the same value. That's what makes them equivalent. Let's move on to exercise 3 on page 34. I love this example. Okay, I'm going to read it to you, and then you're going to work together as partners to solve it. So, Tavon is training for a do-a-thon, which is a race that consists of running and cycling. The cycling leg is longer than the running leg of the race. While Tavon trains, he rides his bike more than he runs. During training, Tavon runs 4 miles for every 14 miles he rides his bike. Part A says identify the ratio associated with this problem and find its value. So turn and talk with your partner. Find the ratio and the value of the ratio.